I'm going to assume that you have some understanding of zone time, general math students, and that you understand different parts of the world or different places in the world, depending on their longitude, have at a different time of day. Now, there are lots of interesting intricacies to our time zones. In a moment I'm going to talk about how we calculate the time zone for particular locations, but we're going to use a simplified version of how to calculate time zones because, like I said, there are lots of exceptions and interesting occurrences in time zones. Like, for instance, China, which is a very large country and appears to cross several time zones, they're all on the same time. China is in one single time zone. Australia, for instance, which is similar in its breadth, has 3 time zones. International Dateline doesn't go straight down like the prime meridian does. It encompasses some Pacific islands so that they can be on the same time as New Zealand. They're closer to New Zealand, I suppose, so they're more of an affinity with New Zealand rather than across the Pacific to the Americas. Now, we don't need to worry about all those interesting intricacies in time zones other than the ones for Australia. And we have Eastern Standard Time, Central Standard Time and Western Standard Time. We just need to know these ones and remember those, that unusual case of the Central Standard Time being 9.5 hours rather than being on 9 hours ahead of Greenwich, or the universal time coordinate. So to calculate the time zone for a particular place, we take its longitude, like here with Athens. We've taken the longitude of Athens, 24 degrees east, and divided that by 15. All right? Now, why do we divide by 15? Well, let's see. How many degrees are there all the way once around the Earth? Well, of course, that's 360 degrees. And how many hours are there in a day? There are 24. 360 divided by 24 means there's 15 degrees per hour. So each 15 degree angular separation represents an hour on the Earth's surface. So that's why we divide by 15. Now you see that after that, we round to the nearest whole number. So Athens is 2 hours. 1.6 is closest to 2. Whereas Mumbai, 73 degrees, divided by 15 is 4.86. That rounds to 5 hours ahead. Okay, let's do some quick calculations. You might want to pause the video and do these yourself and then check your answers against mine. Okay, so I'm going to have a go at it. Beijing. Right, so it's at 116, and we're going to divide that by 15, which gives 7.73. Okay, so that rounds, the nearest number is 8, and we display it like this: UTC, universal time coordinate, plus 8 hours. Okay, now the reason it's a plus is because anything that's to the east of Greenwich Mean Time is positive. That's ahead. So you can guess that anything that's west, like Brasilia down here, is going to be negative. Alright, Moscow, 38 divided by 15 gives 2.53, which rounds to UTC plus 3 hours. And Brasilia, 48 over 15 gives 3.2. So that is also 3 hours, but it's behind because it's to the west of Greenwich. So UTC minus 3 hours. Alright, easy enough. Let's try these ones, where we're going to be determining the time difference between two locations and adjusting our clocks for the second location. So it's 3 p.m. in Rome. What is the time in Tokyo? Now, we must always compare the destinations to Greenwich first. We can't compare them to one another. For instance, we can't just find the angular separation between these and divide it by 15. Okay, I'm going to draw it here. 139 take 8, which gives 131. And if we were to divide 131 by 15, well, we'll check that answer later. Okay, but that is wrong. I'm going to cross it now and come back and show you an example of why that is incorrect. Now, a good way to do this that a lot of teachers like to show is to put a bit of a continuum here. So I'll do that. Okay, so let's pretend that this is the time along the Earth, and right in the middle here we're going to put Greenwich Mean Time, and that's at 0, UTC 0. Alright, so anything this way is to the west, anything this way is to the east of Greenwich. So Rome and Tokyo, they're both to the east. So let's put Rome in at 8 degrees to the east. That's Rome. Now when we divide 8 by 15, we get 0.53. Now that rounds, of course, to 1. So Rome is UTC plus 1. Tokyo over here is a lot further to the east, 139 degrees east. So that's Tokyo. So 139 divide 15 gives us 9.26, which rounds, of course, to UTC plus 9. So we can see that the time difference between these two, Rome being UTC plus 1 and Tokyo being plus 9, an 8-hour time difference between these two. Alright, so if it's 3 p.m. in Tokyo, Rome is 8 hours ahead of, if it's 3 p.m. in Rome, rather, 3 hours ahead of that in Tokyo is 11 p.m. Now, getting back to this that I was talking about here, let's say we just found the angular separation between the two and divided that by 15. So 139 take 8 and divide it by 15. You can see that that tells us 8.73, and we would round that to 9 hours, and we'd be thinking, oh, the time difference between Rome and Tokyo is 9 hours. But that's not true. It's actually 8 hours. And it's very important that we compare both places to Greenwich Mean Time, not to one another. So you might want to pause the video and try this with Cape Town and New York below, and then I'll have a go at it. Okay, so I'll grab my continuum again. Ooh. Let's try this. Okay, so you can just use a ruler to draw yourself a little rectangle if you like, if you find it helps you to visualize. Okay, and here's UTC 0 in the middle. Okay, this time we've got Cape Town 18 degrees to the east. There's Cape Town. I'll just put CT for Cape Town. Okay, and when we do 18 divide 15, we get 1.2. So that rounds to 1. So UTC plus 1 for Cape Town. Okay, New York 74 degrees west. So it's in this direction to the west. 74 degrees that way at New York. And when we divide 74 by 15, we get 4.93. So UTC, now it's negative 5. 4.93 rounds to 5. Because it's to the west, it's behind. So we can see that the time difference between these two places, we're going to add though that -5 and 1 here. So it's actually 6 hours between these two. Okay, so it's 3 p.m. in Cape Town. New York is 6 hours behind that, so we're going to go back 6 hours, which will give us 9 a.m. Righto, so you better go and look at the description for the video now and try some of these zone time questions.